Hello, and welcome to a little video about Target 4B where we're going to have a little introduction to exponential functions. Alright, here is a standard form of exponential functions. F of x equals a times b to the x. A represents our y-intercept, and b represents our pattern. Oh, two t's did not end up happening. That blended. Let's try that again. Pattern. That's better. Now, b is always going to be a number greater than 0. That means if you see a negative, that means it's an invisible -1 in the place where that y-intercept, or a, is supposed to be. So b is always something positive greater than 0. All right, let's do some graphs. Oh, before we do some graphs, our exponential functions have asymptotes. Asymptotes are dashed lines that a curve approaches but never touches or crosses. It will be near the curved line, but it will never intersect. In the ones that we're going to be looking at the moment, the asymptote is going to be the line y equals 0. The reason being, there is nothing, absolutely nothing, that you can plug into x in any of the functions that we are going to be exploring at this point that'll give us an answer of 0 for y. So anything from negative to positive infinity, any number that you can think of, if we plug it into this exponential function as is right here, a times b to the x, we will not get an answer of 0. So this will happen a little later, and we'll talk about it when it does. But at the moment, we will get infinitely close to 0, but we will never cross 0. All right, let's start graphing. Number 1. We're going to graph f of x equals 4 to the power of x. Now remember, standard form is a times b to the x. So this is actually 1 times 4 to the x. The 1 is invisible, and the 1 represents our y-intercept. This part can be done in your calculator, and this is how we would do it. To find out what y is when x is -2, you would type a 4, you would click the little caret button, and then -2 in our calculator and click enter, you would get 1 over 16. You would do the same thing for 4 to the power of -1, and you would get 1/4. Next, we plug in 4 to the power of 0. This should be our y-intercept. 4 to the power of 0 is 1, just like that invisible 1 in front of 4 to the x. Next, we have 4 to the power of 1 and 4 to the power of 2. These give us 5 coordinates. Let's graph them and see what an exponential function looks like. Now with our fractions, we're going to kind of have to estimate, because if I gave you an accurate graph, I would have to make it ginormous. It would take up most of the paper because I would need to split it into 16ths. And that's overkill. So we're going to do our best guess. -2 1/16 is somewhere right there. -1 1/4, I'm going to guess, is right there. Then I have 0 1, 1 4, and 2 16. Let's connect that. Now we have an asymptote at y equals 0. That means we're going to flatten out. Sorry, I'm going to sneeze. Ugh. Anyways, we're going to flatten out there, but then we're going to have a little swoop going up. This is what an exponential function looks like. It kind of looks like a swoop. And here, with 4 to the power of x, it is increasing from left to right. So that's us using a number greater than 1 as a base. Let's see in number 2 what happens when we use a number that's smaller than 1 as our base, how that changes up our graph. As a quick reminder, there is also that invisible 1 in front of our function. So we're going to have 1 as our y-intercept, but let's plug things in and prove it. Alright, we'd be plugging this in the same way in our calculator using the caret button. 1/3 to the power of -2 is 9. 1/3 to the power of negative 1 is 3. 1/3 to the power of 0 is 1, just like our y-intercept set in the function in that standard form. Then we got 1/3 to the power of 1 and 1/3 to the power of 2. Beautiful. Let's graph it and see what that looks like. -2, 9. -1, 3. 0, 1. 1 1/3, 2, 1 9. We're going to connect that with a nice little swoop and flatten it out here. When we have a base that is smaller than 1, but greater than 0, of course, our graph is going to be decreasing. Let's step it up a notch and change our y-intercept. Here I have a 2 in front of my base. So when we plug this into our calculator, when we plug in 0, we should get an answer of 2. If my standard form formula assumptions were correct. Let's see what it looks like. Just like before, you will put it into your calculator. Don't forget your parentheses. And when you want to make a power, you're using that caret button. -2 times 3 to the power of -2. Oh, I don't know why I put a negative there. It should be positive. But anyways, when we plug in -2 for x, we get 2 over 9. When we plug -1 in for x, we get 2 over 3. All right, let's see what we get for our y-intercept. We get 2. Fantastic. Oh no, I'm going to sneeze again. I don't want to start this video over. Sorry, hold on. Тихо! 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 I'm back. All right, let's plug in 1. 2 times 3 to the power of 1 is 6. And 2 times 3 to the power of 2 is 18. Let's graph it. -2 2 9, so I'm going to assume it's there. -1 2/3. 0 2. 1 6. And 2 18. So just like before, our graph is increasing because we have a number that's bigger than 1 in our parentheses. However, our y-intercept is different. And yeah, so it changes up our graph a bit. Let's see what it looks like when we have a fraction in the base, but still have a number there. Sorry, a number in front in our y-intercept that's not 1. So hopefully we get 3 as our y-intercept when we plug all this into our calculator. Let's do it. 3 times 1/2 to the power of -2 is 12. 3 times 1/2 to the power of -1 is 6. 3 times 1/2 to the power of 0 is 3. Fantastic. It holds. 3 times 1/2 to the power of 1 is 3/2. Oh, I don't like that. I don't like how I wrote that too. Let's try it again. 3 times 1/2 to the power of 2 is 3/4. Let's graph it. -2, 12. -1, 6. 0 3. 1 3/2, so that's 1 1/2. And 2 3/4. It's decreasing because we had a fraction, and its y-intercept changed. It looks a little different too. The swoop is just a bit different. It's a bit stretched, or a little, yeah, it's a bit stretched. But it's still decreasing. Number 5. Let's match the following exponential equations to their graphs. I believe that the best way to do this is by checking the y-intercepts, because that was one of the easy things to identify. The y-intercept is the number in front of the base. It's a. So let's identify all of these y-intercepts, and we can match them. All right. Letter A. The y-intercept is 0, 1 because there is an invisible 1 in front of that 2 over 3. Letter B. That intercept is 0, 2 because of the 2 in front. Letter C has 0, 4. And letter D, what number is actually in front of that 5? It's a -1. So letter D is 0, -1. Let's match things up. For letter A, the y-intercept is right, that's not pink. For letter A, the y-intercept is right here, 0, 1. For letter B, 0, 2 is right there. For letter C, 0, 4 is right here. And finally, for letter D, 0, -1 is there. Fantastic. Number 6. In number 6, what we're going to do is we're going to be writing exponential functions for each of the given tables. Just as a reminder, we're going to have f of x equals a times b to the x. Just like I said all the way up here, the a is the y-intercept and b is the pattern. So we need to identify both of those things, the y-intercept and the pattern in which the table is going. All right, letter A. Oh, what did I do? I zoomed in too much. Let's try that again. Come back. There we are. Letter A. Here's our y-intercept. Easy peasy, 0, 2. So we already know what A is. Now we need to find B. In order to find B, we need to find the pattern. And because this is an exponential function, and exponents are fast multiplication, we're going to use some division to figure out the pattern. We're going to do bottom number divided by top number. So 6 divided by 2, which gives us 3. We have all the information we need. Let's write our function. F of x equals 2 times 3 to the power of x. Let's try it again. In letter B, the y-intercept is 0, 3. Fantastic. Let's find the pattern. By using some division, we're going to do 0.6 divided by 3, and we get 0.2. Let's find that it's a decimal. F of x equals 3 times 0.2 to the power of x. Letter C. There's our y-intercept, 0, 4. Perfect. Now let's find the pattern by doing 28 divided by 4, which is 7. So f of x equals 4 times 7 to the power of x. Not too bad. All you had to do is identify the y-intercept and then figure out the pattern. Let's do that again, but this time with graphs. Now, it's not going to be any harder, I promise. But we do need to identify the points ourselves. So we're going to create some mini tables for these graphs. All right. So all I really need is 2 points. I need the y-intercept, and then I need one other point to find out the pattern. Let's do it. Here's my y-intercept. That's 0, 4. Fantastic. And then here is a point that I could use That's 1/12. To find the pattern, 12 divided by 4 is 3. We're good to go. F of x equals 4 times 3 to the power of x. Letter B. Let's do the same thing. Let's use this point and this point. Of course, I'm using the y-intercept, 0, 3. It's a great thing to use and to start with. And then here the point is 1, 1. So to find our pattern, I'm going to do bottom number divided by top, so 1 divided by 3, which is 1/3. So f of x equals 3 times 1/3 to the power of x. Let's do it twice more, and that will be good. Letter C, let's identify the y-intercept. There it is. It's 0, 2. And then we have, oh no, not that. Is it that? No, of course, it's right here. We have 110. We've got our y-intercept. Fantastic. Now let's find the pattern by doing 10 divided by 2, which is 5. We've got everything we need to write our function. 2 times 5 to the power of x. Last one. This one's going to be just a teeny bit different because although I do have the y-intercept right here, I don't have any points to the right. I do have a point right here on the left, negative 112. To make sure that my table is in order, negative 112 is going to be above 0, 3. 0, 3 is our y-intercept. Perfect. Now let's find our pattern. We're going to do 3 divided by 12, which gives us 1/4. Let's put that into a function. F of x equals 3 times 1/4 to the power of x. If you've got any questions, please make sure to ask me or whoever else is helping you with this. Otherwise, have a wonderful rest of whatever day it is for you. Bye!